Morning and welcome back to another exciting lesson with Mrs. Brady. Okay, let's start by reading the bottom as we do. We are going to represent measurement data with line plots. Yes, we are. Okay, let's read what's going on. This looks very similar to what we did yesterday. Yesterday we had, what were they? Bean plant heights. We had all of these bean plant heights, and then we plotted it. Today, we're going to do something very similar, but we have to create everything by ourselves. Ooh la la. We can do it. Let's read about Delilah. Delilah stops under a silver maple tree and collects leaves. At home, she measures the widths of the leaves to the nearest 1/4 inch and records the measurements as shown below. Here we are. So now we're tasked with using the data to create a line plot. We can do this. So if you have your straight edge, that's what I'm going to use to do a little, a line. I'm going to kind of put it up. Well, you know what I'm going to do is I'm going to look at yesterday's problem set to see kind of how we did so we can remember all of the things that we need. Okay, so we had a title, we had the line plot, and then we had the label. So let's title this guy first. What should we name this? Maple tree leaves widths. Yes, let's do leaves. Maple leaves width. Not the best title ever, but that's what we're working with. Okay. Now, let's make a line so we can plot all of our points. Okay. Boop, boop. Boop, boop. Oops, let me scoot that up a tiny bit. We need those arrows on the end because we're not going to start at 0 and numbers go on forever. FYI. Okay. Now we have to figure out our intervals, right? We need to figure out how we're going to spread out these numbers. So what's the lowest number you can find? Can you point to the lowest number you can find? I found 5.5. So I think it's a good idea if we start with 5.5. So let's remember that. And then what's the highest number you can find? Point to the highest number you can find. 6 3/4 is the highest that I can find. So we need to split this into 1/4 inch because that's what they're measuring, right? That's what they measured to the nearest 1/4 of an inch. So we're going to start with 5.5, and we're going to end with 6 3/4. So let's pop those points here. Let's do 5.5. And on this side, we'll put 6 3/4. Now, we're cutting these into fourths, right? So maybe we should have done this on a fourth. It's fine. So how many how many times do we need to partition? If you're doing this with a pencil, there's not as much risk, right? If you make a mistake, you're going to erase. But I don't have that luxury because I am using a pen. So we're going to have, the next one will be 5 3/4, and then 6 1/4, or 6 1/4, and then 6.5, and then 6 3/4. So I think I can make them kind of far apart. Well, I'm just going to start right there. 5 3/4, because we're counting by fourths, right? So now we have 6 inches. Now we're going to have 6 1/4, and then 6 1/2, or 6 2/4, right? And then 6 3/4. That looks pretty good, actually. Hopefully yours looks Even better. And then over here, remember how we did the label? So let's label this. We're just going to write inches down here. We don't need to tell them. We don't have to write label. And then we are going to do x's. So 1x is going to equal what? Say it out loud in your house right now. Yeah. 1x is going to equal 1 leaf. So now that we've done that, we're going to place an X to represent each of these leaves on our line plot. Let's get started. We're going to start with 5 3/4. There we go. Remember how we like to cross them out as we go so that we don't forget what we've done already. 6 1/2. 6 1/4. 6 1/2 again. 6. 6. 6 1/4. 6. Lots of sixes, huh? 5 3/4 again. 6 1/4. 6 1/4. 5 1/2. 6. 6 1/4. 6. 6. 5 3/4. 6 1/2. 6. 5 3/4. 5 3/4. 6. 6 1/4. 6 3/4. 6 1/2. That's a good looking line plot. I like what we have here. Okay. Now let's flip-a-roo and see how to interpret the data or do whatever it's asking us of us, right? So B says, explain the steps you took to create the line plot. Okay. So what do we do first? First, I created a title. What do we do next? Next, I drew the line. Next, I labeled the line in inches. Next, I figured out the scale of the line. So we did, what did we do? We started with 5 1/2, 5 3/4, 6, 6 1/4, etc. Lastly, we plotted, I went from I to we. We plotted the measurements on the line plot. Beautiful. Okay, let's move on to the next one. It says, how many more leaves were 6 inches wide than 6 1/2 inches wide? So remember, when it says how many more, what operation can we use to figure that out? You said subtraction, and you are a little tiny genius. Good job. Okay, now I forgot what it said. 6, then 6 1/2. Okay, so let's count and see how many we have for 6 inches. 1, 2, 3, 4, 5, 6, 7, 8. And how many for 6 and a half? 1, 2, 3, 4. I don't think that y'all need to do this, but I'm going to just to do it. So you have 8 that were 6 and a half. We had 4 that were 6 inches. 8 minus 4 is 4. So I'm going to say there were 4 more leaves that were 6 inches wide. Than 6.5 inches wide. Okay. And the next one says, find the 3 most frequent measurements on the line plot. What does this tell you about the typical width of a silver maple tree leaf? Okay, well, we know that one of them is going to be 6, right? Because that one has the most. So this one's the most frequent. It looks like these 2 are the next 2 frequent. Let's see, 6 and 1/4 inch. Let's count that one. 1, 2, 3, 4, 5, 6. This one is 1, 2, 3, 4, 5. So between 5 and 3/4 and 6 and 1/4 is the typical range of widths of silver maple tree leaves. I'm going to write the 3 most frequent measurements on the line plot are 5 and 3/4, 6, and 6 and 1/4 inches. This tells me that the typical width of a silver maple tree leaf is between 5 and 3/4 inch and 6 and 1/4 inches. Look at that. We have done it. All right, 3rd grade, I will see you again tomorrow for another lesson. Have a great day.